Hello and welcome to the 7th in my series of presentations on the conflict between science and creationism. After a few longer presentations, today's is mercifully shorter, you'll be pleased to hear. Today I'm going to be talking about fossils, which are a primary source of our information about the evolution of life on Earth. As ever, I'm basing my talk today on the slide presentations of the infamous young Earth creationist Kent Hovind. This means I'm going to respond to points raised in his slides, so I won't cover all of this topic by any means, just the bits that are relevant to creationist claims. Lots of these arguments are dealt with in the wonderful archive on talkorigins.org. Please search for their extremely detailed site and read their much more thorough rebuttals of these claims. You can find many of the arguments that I've used here on that site. However, I've added a few extra bits to bring the coverage up to date. Some related topics to this section will also be covered in the future presentations on anatomy and on dinosaurs and men. Also, make sure you watch the earlier presentation on radiometric dating, which is a technique that gives us a fantastically reliable method for calculating fossil ages. The next presentation in this series will also be on fossils, covering the subject of transitional fossils. So, let's get started. Circular reasoning. The argument here is based on the erroneous claim that fossils are only dated by the strata, that is, the geological layers in which they are found. But those same strata are dated by the fossils which they contain. This is apparently circular reasoning. It looks like we're using the claim that fossils are old to prove that fossils are old, which is clearly illogical. Well, of course, it would be if that were the only mechanism we had, and if strata were evaluated entirely in isolation. But of course, this isn't the case. We do have a number of so-called index fossils that occurred only for a short and well-determined period in evolutionary history, and then died out. So identifying any one of these is a very good way to date any rock formation. However, these have obviously been dated separately by totally different methods. In general, rocks are dated by radiometric and magnetic methods that we met in an earlier presentation, as well as more old-fashioned techniques such as examining the ordering of related layers across geographical regions. If layers A, B, C and D lie on top of each other throughout an entire country, but then you find a neighbouring region in which the exact same four strata exist, but they appear in reverse order, a fair bet is that these are the same strata, but that they've been folded back on themselves by geological activity. Often we can find zones where the evidence actually shows how this has happened, with tectonic uplift folding older layers of rock back on top of younger rock. In addition, and this is a minor point, but it's well worth pointing out that the process of stratigraphy was a technique developed by geologists before the theory of evolution was proposed in 1859. Polystrate fossils are another case of anomaly hunting, which is often put forward in favour of global flood theories. Polystrate fossils are those that can be found piercing through several strata in the geological record. Some examples are petrified trees, which often slice through several different types of rock. This is simply because they've fossilised upright and the layers gradually deposited around them. It doesn't, of course, mean that the layers were deposited extremely quickly in a flood, though of course sometimes layers can be deposited quickly, for example in a local flood or volcanic event. Of course, the fact that rapid deposition events exist doesn't say anything for the theory of a global flood. We know exactly how certain rocks form. Some form quickly, like this, and some form slowly, and this is not new to geology. The story of polystrate fossils is heavily misleading for several reasons. Most importantly, almost all fossils are not of this kind. That is, they exist in very nicely defined strata, not overlapping with those from different geological periods and grouped together with other organisms of the same species. The fact that polystrate fossils exist is perfectly in agreement with the geological understanding of rock deposition. However, if the layers were deposited by a flood, we would expect very many polystrate fossils, and the possibility of grouping fossils neatly in layers according to their species seems extraordinarily remote. And secondly, the more amusing side of this is that Hovind seems to use the evidence of polystrate fossils in two contradictory ways. Firstly, he says that polystrate fossils are clear evidence against geologically long timescales on Earth, but then he goes and shows how they can be formed totally naturally in localised flooding and volcanic events. And of course says nothing about how deposits that take millions of years, such as limestone, could possibly be formed quickly. Hovind mentions a lot of examples of fossils that seem extremely strange, such as whales that apparently slice at a steep angle through sediments that are supposed to have been deposited over millions of years. If you examine these claims carefully, you'll find that these examples are all easily explained, usually by pointing out that the strata in which they are found is itself raised at an angle by tectonic activity, and that the fossil is actually lying flat within the geological layer. The mammoth was a large elephant-like creature which first arose about 4.8 million years ago and flourished in the northern parts of Europe and Asia until about 4,500 years ago, when it went extinct, probably due to a combination of overhunting and climate change. Frozen mammoths have been found in an extremely good state of preservation in places such as the Siberian tundra. Often they have remains of their last meal inside them. Creationists claim that this means that they died suddenly in, say, for example, a flood, or maybe a sudden divine cold spell perhaps. Hovin pulls the figure of -300 Fahrenheit out of thin air as far as I can see as an example of the kind of temperature to which these mammoths must have been subjected. Of course nothing of the kind has happened. These mammoths were preserved after being rapidly buried under very cold mud, possibly during a mudslide, at which point the creatures were gradually frozen and mummified. This only happened to a tiny minority of mammoths, of course, but it is enough so that we can find them. Mammoths digest their food very slowly, just like elephants, and as soon as a creature dies, the enzyme manufacturing systems shut down and there is no longer any mechanism for digesting the remains. No controversy here whatsoever. Hydrologic sorting is a very real process that happens when you get a range of items of different size, shape and density in a moving body of liquid. When the liquid slows down and those items are allowed to settle, they will be sorted in order, very approximately, based on their physical properties. Creationists claim that this is the reason why fossils seem to lie in a very well-determined order throughout the fossil record. The idea is, of course, absurd, as even a few moments' thought will tell you. I suggest that the best way to examine this claim is to think of the various types of organism that we see throughout the fossil record, and examine whether, as the creationists claim, the denser ones are really reliably found underneath the less dense ones. For example, buoyant creatures from millions of years ago, such as ammonites, are never found near the top of the sediments as you would expect. But then very dense creatures from today, such as mammals, are always found at the top. This makes perfect sense once you accept the order in which these creatures evolved, and the antiquity of the sediments in which their fossils are found. But if you try to claim that everything was deposited all together, then your argument falls down like a house of cards. A second way to think about this claim is to realise the absurd levels of precision that would be required by this chaotic and catastrophic sorting process in order to produce the fossil beds in the order that we see them today, consistently throughout the entire surface of the world. A global flood should not produce well-sorted sediments. It should produce a jumble of sediments from all different types mixed together, based approximately on density but also perturbed by local variations in the landscape and the flow conditions that would have existed at the time. Hydrologic sorting would not produce beautifully distinct layers of rocks of different types, especially those that we know to have been created very slowly. And that's without the radiometric dating evidence which tells us exactly how old those layers are. Presumably, creationists claim that the decay rate of the isotopes changed based on exactly how quickly during the flood these layers were deposited, or something like that. No, the idea is nonsense and can be safely discarded without any further consideration. The paper that Hovin cites here is one by Mary Schweitzer and collaborators, published in the journal Science in 2005. The authors of this paper found a few millimetre-thick fragments of fossilised material inside a fossilised Tyrannosaurus rex bone that had cellular structure similar to that of living tissue. After dissolving away the surrounding layers of fossilised bone and carefully preparing and rehydrating the sample using a variety of chemical processes, these tissue remains gained a certain degree of plasticity. That is, they clearly weren't crystallised to the degree that we would expect from a fossil. So far, the investigators haven't worked out whether this actually is remnants of living tissue or whether it's merely been chemically preserved in some complex sequence of events. For example, fragments of tissue preserved in amber do exist and have been shown to have been replaced with resin compounds and therefore given the appearance of living tissue. Another hypothesis is that this has happened because the bone crystallised around the sample, protecting small pockets of it from invasion by external forces such as parasites, bacteria, or damaging chemicals. In fact, more recent analysis has duplicated the findings of the first group, but does suggest that a more likely explanation is simply that the sample was contaminated from outside sources. Or, at least, before we start to propose complicated fossilization mechanisms, we should try to rule out the contamination hypothesis. None of this is a problem for an old Earth, of course. Just because a very tiny proportion of fossils seem to fossilise in a very bizarre way doesn't avoid the fact that the overwhelming majority fossilise perfectly normally and over extremely long timescales. Needless to say, of course, the authors are all mainline scientists who agree with the age of the Earth in the billions of years as ascertained by science, and this find, though fascinating and unusual, doesn't seem to have bothered them one bit. And just for interest, the main author is a committed Christian. For the record, the oldest verifiable sample of protein that we have extracted was achieved fairly recently by a British team who extracted a near-complete collagen sequence from the remains of a mammoth that died around 600,000 years ago. So pretty much all of the creationist argument boils down to their hypothesis that fossils can form quickly in the right conditions, and that therefore all fossils formed quickly. This is, of course, a complete non sequitur, and they often neatly sidestep the very many fossils which do not and could not fit their simplistic picture. How long do fossils take to form? The answer is not very well known, but it's not a great ambition to say that bones can indeed fossilise very rapidly, certainly in the 6,000 years or so since the time creationists say that the Earth formed. However, this isn't a problem. We don't date fossils by the time it takes to form them, we date them using other methods, such as radiometric dating or analysis of the strata in which they were found. Also, some creatures are found preserved in amber, a precious gemstone which is formed from tree sap, and this does take at least millions of years to form. The main message to take away from the fossil record is that it is extremely diverse, extremely coherent, and extremely varied. Fossils are found in very coherent locations within the geological strata, in layers that make sense given their modes of life. Fish are found with other fish and marine life, land animals are found together, primitive life are found in the earliest rocks without any larger creatures in the same strata, and animals are ordered in a way that, through the examination of the sequence of body forms, coincides beautifully with what evolution predicts. If one takes a single fossil in isolation, then the picture it portrays is often not very impressive. The real strength of the fossil record, and in fact most of science, especially the science backing up evolution, arises when we realise that every one fossil, every one tiny bit of evidence, is just one of the millions upon millions of such cases that build up a wholly impressive overall picture. I really enjoy walking through the Natural History Museum in London, past the wall of extinct marine reptiles, seeing dozens of fossils from ichthyosaurs or different types, all showing a remarkable range of forms, but a certain consistency in morphology, which demonstrates a thread of evolutionary change running through the history of this one narrow species. Even as early as the mid-19th century, many paleontologists saw the fossil record, as incomplete and unexplained as it was back then, already as a cast-iron proof that the Earth was very old indeed, and that animals of various unknown forms had existed deep in the past. Since then, the fossil record has been expanded greatly and has been backed up with the sciences of geology and radiometric dating, not to mention the genetic evidence, which ties up all the relationships between the various groups of animals that fossils have been suggesting for so many years. We'll be looking at genetics later in the presentation series. Well, that's all for now. As ever, there's loads more information on my website at frame.net, where you can also find a transcript of this talk and all the following ones and all the previous ones. And you can keep up to date with my blog as well as learning about some of my other work. See you next time when I'll be talking about transitional fossils, the special case of fossils that show a transition between two separate groups of animals. Thanks for listening.